Hi, algebra students. Today we are taking a look at piecewise functions. A piecewise function puts together two or more functions to represent a scenario. Graph the function over the given domain. Remember to use an open circle on a point that is not part of the graph, but is needed as part of the inequality given in the domain. So our first example is, at a retail store, pencils can be bought in singles or bulk. The function below represents the cost of the pencils given the number of purchased. Graph the corresponding function on the coordinate plane. So we have f of x equals 10 cents times x when you're buying between 0 and 20 pencils, and then 8 cents of x, 8 cents per pencil, when you're buying greater than 20 pencils. All right, so we have to graph both those functions. The easiest way to do it is pull up both of the functions in your equation first. So we're going to go to y equals and put both of them in. So 0.10 times x as the first one, and then 0.08 times x as the second one, and we're going to pull up the table. So we have the sets of values for both functions that we're going to be graphing. And now we have to set up our actual equation or graphs to our coordinate plane. So on the bottom, it tells us number of pencils in multiples of 2. So every other is going to be 4. Which should get you to 40. And then our cost is in multiples of 20 cents. So I'm going to do multiples of 40 cents every other. It's going to get you up to $4 at the top. All right, so now we can go ahead and graph those two separate equations given the domains that we have here. So again, it's 10 cents for the first 20, from 0 to 20. So 0 is going to have a closed circle, but 20 is going to have 0 is going to have an open circle, but 20 is going to have a closed circle when we graph it. So starting at 0, we have 0 and 0, obviously. Then we can jump to 2 and do 20 cents. Then 4 would be 40 cents. 6 would be 60 cents, and so on until we get to 20. Where we need an open circle because that's when we jump to the next price value. And we could draw our line through those points. So that's the first part of the equation, the 10 cents x part. Then when we jump to the second one, we go down to the 20th value, which is going to be at $1.60. And we're going to put our first closed circle there, and I'm going to go up just so I have 20 at the top of the equation or the graph. So 20 is at $1.60 now. So I'm going to put my open circle or my closed circle there because that's how much 20 pencils is going to cost me. And then it's going to go up by 8 cents for each one. So 21 is going to be at $1.68. 25 is going to be at $2. So it might be easier to just graph the ones that are whole numbers, so I'm not really estimating. So 25 would be between 24 and 26. So 25 and then $2 brings me to right here. Then 30 and 240. So between 28 and 32 up to 240 is here. 35 and 280 would be right before the 36 and here. And then 40 is going to be 320, which is here. And that's as far as my graph's going to let me to go, although we know it would go further, so I'm going to put an arrow on the end. So that's my piecewise function that represents the cost of the pencils at this store depending on how many pencils we buy, giving us a discount or a little break if we buy 20 or more. So you're going to use this graph to answer the following questions. All right. So now our second example is a taxi cab company charges customers differently depending on how far they must travel. The function below can be used to determine the price of the cab ride as a function of how many miles are traveled. So here we want to again have three different equations that we're going to have to graph. So we can go back into our calculator, clear the equations from the last problem, and enter in our new ones. So we have 2.5 x plus 5. So that's like 2.5 per mile plus a $5 initial charge. Then 2.25x plus 6, so that's $2.25 for per mile plus the $6 for your initial charge. And then 2x plus 8, which is $2 per mile plus an initial charge of $8. So then we can pull up our table and we'll have three sets of values. We can go back to second and window to start at 0 instead of scrolling up. And we'll have, again, we'll see our y-intercepts. There's 0, 5, 6, and 8, which are the initial fees. All right, so now we have to set up our graph. So our distance on the bottom is in multiples of 2 miles, so every other can be 4 again. Which gets us to a total of 40. And then our cost is going to be in multiples of 5 or every other by 10. So 10, 20, 30, and so on. Okay, so now we can go ahead and graph those three equations that represent the one piecewise function, starting with 0, 5, and that first equation until the 10th mile. So we go from 0, 5 to 1030. And honestly, guys, a line is made with 2 points. So we don't have to be crazy about drawing all of the points in between. We can pick some of them, or we can do the first and last. So we know 10 is at 30. So really, this is my line. Only thing I did wrong there is, the 0 doesn't really matter as a point. Okay, you wouldn't be charged $0 for 0 miles. And in this case, because there's that less than symbol, we can make it an open circle, and the less than or equal to would be our closed circle. Okay, so just pay attention to that. All right, so that's the first part. Then the next one, if we go over and down past the 10, from 10 to 20, starts at 2850. So 10 miles, and 2850 is a little bit below the 30. I'm going to put my open circle, and that's going to go all the way to 20, which is going to be at $51. So 20 and 51 would be about here, and I can draw my line between the 2 points instead of estimating all those ones in between. And then the last one goes from 20 and on. So we know that 20 now is going to be 48, so an open circle below the 50. And 30 would be at 68, so at least let's go to there, and we can draw our line past that. 30 and 68 would work, and we can do 40 as well just to get another point in there. That would be at 88, so 40 and 88 would be right below the 90. So about there, and I can draw my line and extend with an arrow on the end. So that is my piecewise function that represents the cost. So now it says how much will 8, 15, or 30 miles cost. So we know 8 would fall in the first category because it's between 0 and 10. So we can go right back to our table and find value for 8. The value for 8 would be $25. Then the 15 is going to be between the 10 and the 20. So we can go to 15 between 10 and 20, and that's the $39.75. And then the 30 is in the last setting. And that would be the 68 that we saw before. Okay, so hopefully you're seeing that this really isn't that hard. You just got to make sure you're paying attention to the domains that are given to graph each equation over. All right, let's try one more. So now Jared is saving money for college. He starts with a piggy bank, then opens a savings account. The function below can be used to determine the amount of money saved on each of his birthdays. All right, so he starts with 300x, and that's from 0 to 5. So in his bank every year, he was saving $300 from the years of 0 to 5. Then from the years 5 to 12, he had $480 per year minus the $900 that he already saved the previous years. Then 4,860 times 1.025 times or to the x minus 12 is from year 12 and on. And we'll see that these kind of connect and match up. So how much money will he have when he is 20? We'll figure that out once we start the graph. All right, so we're going to go into our calculator, clear what's there from before, and enter these new equations. So we have 300x, then we have 480x minus the 900, and 4,860 times 1.025 to the x minus 12. All right, so we pull up our table. Uh-oh, what did I do? So we go back to y equals, second quit y equals. Oh, I didn't put this in parentheses, that's why. All right, that should be right now. Let's see, second table. There we go. All right, so we can go back to our beginning at 0, pull up our tables, and we have all the values that we need here. So starting with the 300x from 0 to 5, but first we need to set up our table. So we have 0, and we have to get to 20. I believe it's set up so there are 20 boxes, so I'm just going to do every other by 2. Yep, 20 is at the end. Then we have our savings and multiples of 300. So we're going to do every other by 600. So we get up to 6,000. All right, so now we can start graphing. So our first graph is that 0 to 5. And we have to graph carefully. So 0, 0 is included. So we put our closed circle at 0, 0. And an open circle is going to be at 5 because that's when he changes how he's saving. So 0, 0, or 0, 0 is our first point, then 1, 300, then 2, 600, then 3, 900, 4, 1200, 5, 1500 with an open circle. So there's our first line. Now we're going to jump over to the next graph. So 5 stays at that 1500. So I can basically close my circle. I'm going to put a dot in between. And then we go to 6, 1980. So we're going to have to round a little bit. So it would be about here. And then 7, 2,460. And 8, 2,940. And it should look like it's jumping up about the same amount each time because it is a linear function. 9 is 3,420. 10 is 3,900. Which is actually right here. And 11 is 4,380. And last, 12 is 4,860. And that's going to be an open circle because, again, that's when he changes how he's saving. Okay, so we've got that line there, those two both being linear functions because they're in y equals mx plus b format. Now the last one is an exponential function, and we start with 12 being at 4,860 again, so we're going to close that circle and then follow. Now remember, an exponential function has a little bit of a curve to it. This is going to be a hard one to see because it's going to be a very wide curve. It's almost going to look linear, but it's not. So I'm just going to pick a couple to graph. For example, the 14 and 5,106 would be about here. Then the 16 is about 5,364. So like here, I feel like this one needs to go down a little bit. And the 18, 5,600. So this is 54, so that would be 57, would be about here for the 18. And then the 20 is about 5,921, so it's under that 6,000 mark. So we have our little curve right here that would keep on going like that. Okay, so how much money will he have when he is 20? So we see that in the table right now. 20 is highlighted. If I bring it over, we can see exactly the dollars and cents that he would have. So he would have about $5,921.44. Okay, so that is how you do a piecewise function. Take your time. You're going to try and answer some of those exit questions, and then you can move on to today's homework.